Since last few lectures, we are still trying to understand to ourselves what we mean by discrete time Fourier transform. In that discrete time Fourier transform, which happens to be summation over n for xn e raised to minus j omega n, in order to simplify the understanding, we have divided that x of omega is comprised of two components, xr omega and xi omega, and each of them are summation over n xn cos omega n and xn sin omega n. Then when we noted down about the nature of cos omega n or sin omega n, as the case may be, we have found that it is oscillatory. As it is oscillatory, its own sum over n is likely to be very much near 0. Then we are considering how the sum xn cos omega n grows for different omegas, and in that attempt we have noted down that the sum will grow for particular omega if xn is having a behavior which is similar to that cos omega n. Then we had started developing a theme which is yet at very infant stage, that is x of n is considered as comprised of multiple sequences, x1 n plus x2 n plus x3 n and so on, wherein is it now possible for us to have each of them as good as ai cos I delta omega n. So we were talking about, is it possible? We can think of, there is no harm, as xn is comprised of summation of xin, I starting from 0, let us say, and ranging to n minus 1, and n may tend to much more, may tend to infinity. So we are considering a sequence comprised of multiple subsequences, and now we are considering a situation where is it possible for me to define these subsequences to be sinusoidal sequences. So the question before us is, can I write any sequence? Is there a problem?
No, sir.
Can I write any sequence comprised of such subsequences so that each of these subsequences is essentially a sinusoidal sequence, obviously of different frequency and different amplitude? So is it possible for me to find out for every xn, can I write each xin to be equal to, where xin is equal to some coefficient ai, some coefficient, a constant ai multiplied by cos I delta omega n, where delta omega is equal to 2 pi upon n. And then the question is, for some sequences it may be possible, suppose let us say that original xn is some cosinusoidal signal only. It is likely if original xn, let us take most simple case, xn itself is cosine pi by 2n. If my xn itself is cosine pi by 2n, then naturally there is no need to represent it as summation of multiple sinusoids, because my original xn is one sinusoid itself. Are you getting me? My original xn is one sinusoid itself. So in this term there would be only one term, for there would be one the ai, this amplitude is 1, and for a particular frequency component only we do get this. So, so what will happen further? We have noted down that basically I again would like to recite why we are doing this thing. The reason is that we have noted down that the summation of a sequence multiplied by cos omega n summed over n results into a large figure if the sequence for a particular omega, if the sequence itself is oscillatory in a similar nature to cos omega n, and that too, what we can say, maybe in phase or even if out of phase, it will sum to a negative large value. Means if the product xn cos omega n is always positive or always negative for every n, in that case the sum will grow in either side. Then when that will happen, if xn is changing in a similar manner to cos omega n. So when I am finding out xr omega, when I am finding out xr omega, I am trying to find out, as it is a summation again, whether there is some component in xn which is varying like cos omega n. That I am trying to find out. Then I may not get a complete idea directly here. Therefore, let us say for time being, I am successful. For time being, because we are assuming what would be the cost, that my assumption may fail. Let us say for time being, it is possible for me to represent one particular xn as summation of multiple sinusoids given in this manner, and I am successful in developing this summation for capital N equal to say 8. Means if I am able to write down xn as x0n plus x1n up to x7n, where x0n is a0, x0n is a0, cos 0n means only a0, right, plus a1 cos omega 2 pi by 8, right, 2 pi upon 8, that is pi by 4, that is pi by 4, right, this cos pi by 4n plus a2 cos pi by 2n, like this. If I am able to write it like this, then what I conclude, while finding out xr omega, I can find xr omega as this summation, which I can write as separate summations. a0 cos omega n plus a1 cos pi by 4n cos omega n, and so on. And what I find is that, what will be the conclusion? What will be my xr omega? My xr omega would be, which is a function of omega, which I can plot. XR omega is summation x0n cos omega n plus summation x1n cos omega n and so on. Now each of these components, what is x0n? X0n is A0, which is constant now. So let us concentrate on this. X0n is A0. X0n is A0. So A0 cos omega n for n from minus infinity to infinity. A0 cos omega n for n minus infinity to infinity. So what this summation would be? Forget about further terms. Only consider first term. Summation n equal to minus infinity to infinity A0 cos omega n. What this sum would be? Always for omega equal to 0, what will happen? For omega equal to 0, what the sum would be? Sum will not be A0. This would be 1. And summation of A0 for n equal to minus infinity to infinity. So what it would be?
Impulse.
It would be having an infinite value at omega equal to 0. It will be having an infinite value at omega equal to 0. Correct? And 0 value elsewhere. Why? Straight away A0 comes out. A0 comes out of it. And then summation. A0 and summation cos omega n. For omega other than 0, it would be 0. It can be verified by you by appropriate thinking. For omega other than 0, sum of cos omega n over entire n becomes 0. And for omega equal to 0, sum of cos omega n becomes 1. So it becomes infinity. So A0 to infinity is infinity. Then at omega equal to 0, this term, so the first term, what is the first term? First term is infinity. Actually again when we talk infinity, we can say that A0 multiplied by infinity. It is actually impulse of A0. Infinity at omega equal to 0 and 0 elsewhere. Now look at the second term. Cos omega n. What is x1n? x1n is A1 cos pi by 4n. A1 cos pi by 4n. Right? So A1 comes out. Summation cos pi by 4n cos omega n. Summation cos pi by 4n cos omega n. What happens to this summation? Summation cos pi by 4n cos omega n becomes summation cos square pi by 4n. This becomes summation cos square pi by 4n at omega equal to pi by 4, and elsewhere it becomes 0. What is cos square pi by 4n?
1/2.
Cos square pi by 4n is half. Cos square pi by 4n is half. So it would be impulse of A1 by 2. Impulse of A1 by 2. So at omega equal to 0, we get impulse of A0. At omega equal to 1, we get impulse of A1 by 2. And we will go in this manner. Are you getting me? Means if ever we become successful in writing any signal or any sequence as summation of multiple sinusoidal sequences, then if we take discrete time Fourier transform for each sequence, sinusoidal sequence is an impulse function at the sinusoidal frequency and obviously zero elsewhere. Therefore, we can have the discrete time Fourier transform for entire sequence as we can have discrete time Fourier transform of entire sequence as chain of impulses. We can have discrete time Fourier transform of entire sequence as a chain of impulses. Now, for some sequences xn, for example, the simple most is if xn itself is sinusoidal sequence. In that case, there may not be any need of further decomposition. Are you viewing the previous recorded lecture? Because this may be a good theme that somehow another student is unable to understand something in the current lecture. At the same time, he or she understands that the background was discussed in the previous lecture. So, on the mobile, then for this will require contained addressable mobile. And if it is so that yes, at what time this word was spoken, based on that you automatically go there and view the link. Anyway, so if the original signal is sinusoidal signal, in that case the decomposition is not required. Not required in the sense.
Wrong number.
So if the original sequence itself is a sinusoidal sequence, in that case the question of representing it as summation of multiple sinusoids doesn't arise. It is a single sinusoid. But if the original sequence is not a single sinusoidal sequence, then we are now checking a feasibility of representing xn as summation of multiple sequences. And further, we are exploring the possibility, is it possible to consider each of these sequences as a sinusoidal sequence of very different amplitude and different frequency. We always have a further scope because it is yet not clear to specify the given sequence as summation of how many sequences. So we can start with, first if it is sinusoidal, then it is a single sequence, summation of only one sequence. If it is not, then we can try whether we can represent it as sum of two sequences. If not, three sequences. If not, four sequences, and like that. So always there would be a scope to increase the number of sequences of which the given sequence is comprised of, and then try for it. And since n is a countable infinite, you can always try for further thing. Therefore, we can always say, means what a person who is appearing for, these are the conventional jokes at a high school stage. A person He will always say that if I do not pass in this March examination, then ensuing October examination is there. At autonomous stage, we are having re-examination. So that every time there is a hope. There is no question of losing the hope. Similarly, if you cannot succeed for decomposing given sequence into a sum of 3 sinusoidal sequences, try with 4. If not, try with 5, try with 6, and like that. Just like now, whether the prime numbers have an end value. So there is always search going on that it is the largest prime number found, and after that algorithms are running for finding out next larger prime number. So similarly, for any given sequence xn, always the attempts should be to try to see whether we can represent it as summation of multiple sinusoids, and the number of multiple sinusoids which are comprising this original signal may increase. So if ever, let us say that why should we presume that we will fail? Are you getting me? When it's a positive thinking approach. Is he locked in finding out the number of sequences? So we should always have wishful thinking that for any given sequence, it will be possible for me to decompose it as summation of multiple sinusoids for some value of capital N, which may tend to infinity. Then, whenever that is achieved, so I can look as discrete time Fourier transform for that is a train of impulses. A train of impulses. Then, further thing which comes into picture is, as I am looking it as summation of many sinusoids, these coefficients go on reducing substantially. So when coefficients go on reducing substantially, when these A0, A1, A2, or when these AIs, why we were getting this product as infinite? Why we were getting this product as infinite? When A0 was finite and this was infinite. So it was infinite. When capital N grows much larger, each sequence is summation of infinite sequences, then again by common sense one can presume that these coefficients AIs start reducing and they reach infinitesimally small values. So we look at a hypothetical situation that given xn is comprised of infinite subsequences. Given xn is comprised of infinite subsequences of different frequencies and infinitesimally small amplitudes. We are reaching to a limiting case wherein a given sequence is looked as summation of infinite subsequences, each with different frequency. Different means what? Immediate next. Immediate next means as what is delta omega? It is equal to 2 pi upon n. So I am trying to find out that given sequence is comprised of sinusoids of this frequency plus this frequency plus this frequency plus this frequency and so on. Every point I am aiming at because as n is growing, the next frequency component is coming very close to the current frequency component, because it is changing by I delta omega. I equal to 0, so 0. I equal to 1 delta omega, 2 delta omega, 3 delta omega. So those will come, the spread will reduce. And again, by common sense or intuition, we can think that the coefficients are becoming infinitesimally small. Coefficients are becoming infinitesimally small. So if coefficients become infinitesimally small, then what will happen? What will happen to these individual components? A0, or let us say A1 into cos pi by A1 cos pi by 4n cos omega n. A1 was coming out, and cos pi by 4n cos omega n. Cos pi by 4n cos omega n was having a constant value of half for omega equal to pi by 4 and 0, and varying for other omegas, and summation was resulting into 0 for other omegas, and summation was resulting into half into infinity for, or in that matter we can say half into 2 infinity, because if you look at minus infinity to infinity. So half into infinity for omega equal to pi by 4, and that was getting multiplied by A1. And since A1 was finite and the summation was infinite, we were saying that it was infinite. But now we are in a situation where these coefficients are becoming infinitesimally small. If these coefficients become infinitesimally small, then what happens? Then the product of an infinitesimally small value and infinitely large value becomes finite. So, can you think of a limiting case of discrete time Fourier transform? A discrete time Fourier transform in its most simple case was 1 impulse or 2 impulse or 3 impulse, 4 impulses. But the impulse values were reducing. And if it grows continuously, in that case it will no longer be impulses. It will no longer be impulses. The moment at which the number of impulses become infinite, actually it is a chain of impulses, and in such a manner that area of first impulse, area of second impulse, area of third impulse, like that, it sums to a finite value. It sums to a finite value. It is actually connected to energy in the signal. So if it is being taken as n tending to infinity, the impulses will join, and when two impulses join, you think of a situation where there are multiple impulses. Each impulse is having some area. The number of impulses are growing. Number of impulses are growing means impulses coming together to each other. The values of impulses are reducing. So, what would be a limiting case?
Only one.
What?
Only one.
One what?
One impulse.
Why one impulse? See, others deserve to comment if they are having something in their mind.
Empty mind. Like this.
are multiple impulses. Now, it is always possible to have one impulse at the middle point of two impulses. Further. And it is never ending. And what we may think of is when you add one iteration of impulse, the value of impulses gets proportionately reduced. Value of impulse is what? Value of impulse is that it is a comparison between infinite amplitudes. A value of impulse of 2 and means an impulse of 2 and impulse of 3. Both are having infinite height and zero width. But areas are different. Those have degenerated from the rectangles of different areas. So in this manner, let us have a very simple case. I would like that everybody of you should understand the concept of envelope. Let us say that from 0 to 2 pi there were some impulses. Let us say there were originally 5 impulses. Right? And their amplitude, their values were something, let us say A0, A1, A2, A3 and A4. So what is total area under the curve? It's a curve actually again. So total area under the curve is A0 plus A1 plus A2 plus A3 plus A4. So total area is A0 plus A1 plus A2 plus A3 plus A4. Area is finite. Now, if what we are doing, if I add one impulse in between these two, like this. So I add 4 impulses. Then when I add 4 impulses, area is not to be changed. If area is not to be changed, in that case, these impulses should have some values, maybe A0 plus A1 by 2, like that. But if I add, so area will increase. So when I add these impulses, what is by common sense we can think of is the values of when I am adding 4 impulses now. Since it is very much 5 and 4, I can't say divide by 2. But if it is say originally there were 10 lakh impulses, and in between I add again 10 lakh minus 1 impulses. So it is as good as doubling the impulses. So areas of original will reduce by half, and area of impulse added in between would be average of these two neighbors. Are you getting me? So this I make A0 by 2, this I make A1 by 2, and this I make A0 plus A1 by 2, and I go on like this. In that case, what is going to happen? Area will be same. So if I iterate further, what will happen? So, and what? It is continuous. But will it remain an impulse? It will not remain an impulse. So impulse will degenerate to a point, and we get some curve such that this area is equal to A0 plus A1 plus A2 plus A3. So limiting case of discrete time Fourier transform is like this, where I can look the original sequence is comprised of infinite sinusoids. Original sequence is comprised of infinite sequences such that each of them is a sinusoid. It's a very difficult thing to be visualized, but if you adopt a systematic and stepwise approach, I do not see any difficulty in coming to this conclusion. So, and this is true for any sequence. For sequences which are of simpler nature, we may achieve this decomposition in finite steps. Are you getting me? So what we are doing? We are trying to decompose. We are trying to decompose the given sequence to be comprised of summation of multiple subsequences. For some sequences, we may achieve this decomposition in maybe 1, 2, 3, 5 sequences. Whereas for some sequences, we may not be able to achieve. We need infinite subsequences. So if infinite subsequences are needed, then discrete time Fourier transform is a continuous curve. If it is possible to achieve this in finite subsequences, then discrete time Fourier transform is a train of impulses. So we may take some simpler examples further. We have a simple sequence. Xn is equal to minus 1 raised to n. Xn is minus 1 raised to n. Find out discrete time Fourier transform for the same. Xn is minus 1 raised to n. Means for n equal, for even n it is plus 1, for odd n it means it's a train of 1 minus 1, 1 minus 1, 1 minus 1, like that, that's all. So how can I look it as summation of multiple sinusoids and find out discrete time Fourier transform means xn e raised to minus j omega in summation, or look x omega as a joint group of xr omega and xi omega and find them separately. Find them separately. Discrete time Fourier transform understanding is difficult and complex in the sense that I would like that every individual who is studying this course should have some kind of visualization of discrete time Fourier transform with themselves. The only problem is that the visualization of discrete time Fourier transform of an individual happens to be what kind of perception he or she develops, what kind of image is getting prepared on his or her mental screen the moment at which he or she listens the word discrete time Fourier transform. But the problem is that the image prepared of discrete time Fourier transform of an individual is not transferable, means he has got a good camera of today costing 13,000, scholarship is yet due. Even after you full scholarship of all the students in the class, it would be impossible for you to have a camera which is able to capture the image of an individual's mental screen. So you can appreciate the problem like this, that I have got one impression of discrete time Fourier transform with me. It is not possible for me to project it on the screen so that each one of you can see and copy it. Means now there has been statements that there are people who have understood something but they don't want to share. It is not always true. There is a situation where even though an individual likes to share, the question is he cannot share because the image is not transferable. Therefore, by alternative means, I am trying to create an image on your mental screen about discrete time Fourier transform. Then you can just imagine how difficult the assessment is, because as you cannot see image on my mental screen, its counter is also true. I can't see the image on your mental screen. Then how should I assess whether you understood properly or not? Then I need to ask some questions by which I can prepare a perception of image on your mental screen about DTFT. I can't see that. So I have to construct that image without seeing the image by asking some questions. Based on that, I may get some hints about the image of discrete time Fourier transform which you carry with you on your mental screen, and then I will compare the perceived image of your mental screen with my image, and then I would be in a position to assess how you have progressed. And again, this image is not a final image. Just like the noted singers do not leave the practice of doing riyaz every day, because from that recitation their concepts are becoming more and more clear every day. So even though a broad image is prepared, when you paint a picture, you may paint a schoolboy starts, means what is given, there only chalk pieces. So the only thing given is that have a, for the face give brown, for the shirt then give something like red and all that. But as, so that is over, but then you go with watercolors. So each time you can give finer and finer shades and the picture will never be complete. Same is the concept of developing the image of discrete time Fourier transform. So as the noted singers like Bismillah Khan maybe, Pandit Bhimsen Joshi maybe, they every day in the morning they wake up and do riyaz of various ragas. Likewise, an electronics and telecommunication engineer should think of Fourier transform, Laplace transform, then Z transform, discrete time Fourier transform and discrete Fourier transform coupled with discrete cosine transform. So if you get a leisure time, you should start think, you should switch. Now I will think on discrete time Fourier transform. I will update myself. And you may have mobile clips with you, having some snapshots of the lecture. And based on that, so that will act as stimulation to think. And you may refine your image. I suppose that even if at the end of the course everybody accepts that these transforms are to be recited by them for lifelong, then it would be serving the purpose of the course. Thank you.